share. Can you guys see my screen? Okay. All right. So what we're going to talk about today are variables or types that you create yourself in order to store some information. So you'll have noticed that we really never touched on variables. And that's generally because in Haskell, you try and do as much with functions and chaining functions and binding functions and the results of functions together so that you don't actually use variables so much. But sometimes you really need data to be stored so that then you can access parts of it and return parts of it and keep things organized. And so that's where the new type and data keywords and information management come in. And so, well, what coffees are we drinking today? I already finished my coffee earlier this morning. Maybe you're having tea, but all drinks are welcome. So a little bit of background, a little bit of going backwards and reviewing what we did a couple of times ago was this bind operator. And if you remember, the bind operator takes monadic things and binds the result of one, basically takes the innards out of one type and applies it to the innards of the next type through a function, and then returns the result of whatever that original type was back. And so we had what was the monad. It was anything that defines that bind operation and has this applicative function that says you have some constructor of type A, then it takes a function that takes a type A and then returns a constructor of type B, and then returns that constructed type again for type B. So you might have had a maybe A, and then you have a function that takes an A. So say it was a maybe string, and you have a function that takes a string. The return type of that function would be a maybe B, which generally is a maybe string. And then you might bind it to another function. So it would return that value. But if you wanted to take that value and apply it to some other or bind it into some other function, you would then have chain on the bind with another function that takes that MB, which is most likely the same as an MA, like maybe string again, and then a function which takes a string and returns a maybe string. And then you keep chaining them together until you produce something that is monadic and return the type. And so it just allows you a simple way to chain functions together, operating on a single input or an initial input. And this is why we say we don't really use variables so much, because you can do these things with the type functions where you have one input that's say read from an input in the terminal or whatever, and it operates multiple times across multiple functions on that input and then produces some output. And one of the things that was an instance of monad was maybe, another was either, or either string or either something. But you'll see if you look at the information about monad, you'll see all of the monadic instances that have been defined in the base library of GHC. There's a bunch. Anyway, so now we're going to talk a little bit about, oh, does anybody have any questions about the monad and stuff like that we talked about a couple of times ago? Anybody practice with their monads? Anybody try and get functions working? Maybe.
I have a question actually about monads. I'm curious to know, I guess, about the structs when you're making a data type into a monad or like a new type. Is that too ahead or?
Maybe.
Okay.
And it might be more complex than what we can cover in this class. But maybe we'll talk about it. We'll talk about, yeah, how do you make your struct or your data type into something that is monadic, right? How do you apply, how do you create that bind operation? How do you define that bind operation on something? So that is a little complicated.
Okay.
But yeah, we'll for the most part, we're dealing with types that kind of exist and already exist with the instance of monad in them.
Okay.
But yeah.
All right, then let me take a mulligan on that and rescind that. But I want to know more, I guess, about, because I going from functors to applicatives to monads and kind of trying to remember, okay, well, this is what a monad is. You can now bind things. You have this wrapper now. But then you kind of forget what applicative does. And it's like for iteration because it follows functor. But then how I guess what's the concrete law on applicatives? Yeah.
So we don't really go into applicatives,
Oh,
but
okay.
applicatives are the constraint, right?
Mhm.
And something that's applicative applies to a type, right?
Oh,
But I think we have to go into that. Maybe we can cover it a little bit next week about like what applicative means and how you would put the constraint for something that's monadic in and something that's applicative, right? Or something that's applicative, something that's monadic has to be applicative,
right.
right?
It's not like the dot operator. I know that, but when I've used the angle bracket with the $sign and I've fed one, I guess, applicative type method to another, you're passing it from after it iterates over because it's a functor. It does its iteration and you throw it to another method and then it does that iteration again. I think. Okay. So that, yeah, so I guess that's my question is it's like, I don't even want to ask because I feel like I'm just going too far left field. So I'm gonna hold back on that. Okay. So that's important to know. It's just monad basically right now is what you're saying. Like that will get us far enough. Because you don't need to have to write all the interfaces for it afterwards, because
especially if you're using sort of simple types or types that have already had the definition to bind.
Got it.
So like even if you're writing like Plutus code, or Haskell code using the Plutus libraries for Haskell development. You're gonna come into contact with new types, new data types or whatever, and those have already had the monadic instance defined on them, right?
Mm.
And so you don't really need to go in depth until you're creating, like what you said, you're creating your new types, and then you're looking at how do I define the applicative how do I make sure that there's a functor that
Mm.
operates on it, how do I make sure that it operates within the semi group, things
Mhm.
like that. um, uh, so you just so maybe we'll talk a little bit about that later next week, um, where we talk about we can talk about applicative and defining applicative and functor on your types. So
Okay.
that'll be more in depth, maybe an optional lecture.
Apologies, but yeah. Okay. No,
Yeah,
thank you.
yeah. Okay, so what are new type and data, right? So we've seen let and inside lets you might create some variables, and we did that a couple of times, but then we've since not really used that. Maybe we've stored something in a variable, but maybe we've instead used the bind operator and just passed in some input to a series of functions that operate on the monads. But sometimes you really want your own types, and you don't want to use the existing types because, say, you want to restrict your new type of string from being concatenated with an existing string, unless you do some processing on that type of string to produce a string. And so how do you prevent that? How do you make that a requirement? Well, you create new types for data types. So data creates you would make a constructor of a certain type. So say we're making a new integer type that you don't want to be able to just add to a regular integer or something like that. Well, here it would work, but there are certain structures that we'll talk about in a second, which make the addition of say a new type hold on. Say that where you would want to be able to use your new data in calculations or not, depending on how you defined what that data type was or that new type. And so the other option, other than using data with this new constructor, new int, or whatever you're calling your constructor and whatever type it adheres to, you might use new type. And you might ask, well, aren't these two things doing the same thing? Almost. So you might say, they look the same, do they operate the same? And the answer is yes and no. Data new type, new int is what they call lazy, and new type is not. And even though you often want your code to be lazy inside of Haskell, you don't exactly want your types always to be lazy in terms of what the compiler has at compile time, but also at runtime. You might want the data types to be already embedded in the code and have to operate in a certain way so that your code doesn't take as long to operate by inferring the types and stuff like that in a lazy manner. So a new type for simple types might be preferred, but we'll get into when you can't use new type and when you have to use data instead of new type. So we're talking about using the new type and data. So according to Haskell language server, new type is always preferred, right? For simple constructions like this, or when you have a single record element. And we'll talk about records in a second. New type adds the constraints at runtime that are not lazy, and data's constructor is removed and sort of whatever the underlying type is used. It's sort of like, but it tells the running system that still you should operate on this other type when it's data as another type rather than the underlying type that was being constructed. And so I'm going to show a little example. Share. Okay. So here we have can you see, let me put it on the right screen. Can you see this, these examples of the new type and data on the screen? So you can do the same things with either. You can also derive show on either type, the new type or the data type. But then you might say, what about a record type? So record types are kind of an interesting type. They are a type constructor, right? And then the type can have embedded other types. So we have this type called a thingy type, and you have this constructor thingy type that takes a record, and a record is names of sort of accessors, and they have a particular type associated with them. And then you can also derive, just like you had derived on the new type or data type, simply some show to show a record as though in its simplest form. And you'll notice up here the underline here for this simple type of new int, it says, why don't you use new type because it decreases laziness. We're going to leave it there because we're just showing that you can do both types. And so the way you construct an instance of this thingy data type. So by the way, you cannot do this. You can't make a record type that has more than one element as a new type. You'd have to do a data type. However, if you did new type, new type, simple thingy, you might do simple thingy, and then you would have say a simple thingy only has a thingy name. This is okay. You could also derive show just like you could earlier. So this record is fine because it only has one it only has one constructed value inside the type. However, with the data type, you can have multiple types. And it's pretty common when you're dealing with data, like in the Plutus ecosystem, that you would use data record types to store some information while you're calculating or while you're lifting some variable up into the Plutus language space, or with your like templated Haskell, you might use these record types. And the question is, how do you go? So the earlier question of how do you instantiate the monad kind into that monad kind. We'll talk more about that next week. But then how do you create a simple thingy or a thingy? Well, you create a thing that is of thingy int. So why do we need int? Well, here we had thingy of type int, but if we wanted to say that the thingy was of type int, we would make sure that the thingy was instantiated with an int here in whatever A was constructed as. So if we run this, let me uncomment. This, run it. So that A up there is of type int in this instantiation, but you might have data, thing two of thingy float. We had thing two equals thingy name second thingy thingy value. And if you look here, if you tried to write F here, and thingy direction up. Oops. You'll notice here that F is underlined, because it's expecting a float. So you might say 35.2, and that works. And so if we ran this thing where we said thingy value on thing 2, and then we ran this, if you look here, load, you'll see that this original thingy, because we have the instance of this deriving show, then it'll output the basic record syntax output, where it's showing all the values. And remember, this is a thingy int, and the thingy 2 was a thingy float, and so the thingy value is a float here. So if we did type of thingy value thing 2, you'll see that it's a float here. But if we did thing value of thing, it's an int. And so you can create these data types that are that have some level of abstraction in them. And so they become sort of very convenient for storing your data and being able to use it in different situations. So you might create for your project you're creating for this class, or for whatever you're doing, you might need to create some structure that holds on to your data. We share. Anybody have any questions about this? These thingies, or these record types? Let's see. All right. So that's all I wanted to cover today for new types and data. But if you look, actually, let me reshare that thing down here. If you notice, so I output the new int type there. If you tried to do B, which is if you give the type of B, it's a new int, and you tried to add B plus 5 int, it would say couldn't match expected type int with actual type new int. And even if you tried new int 5, it would say there's no plus operation defined for for this. So how do we define those plus and operations, and how do we define functors on our data types? We'll talk about that next week, and maybe that'll satisfy some curiosity about those things next week. In the meantime, why don't we discuss how people's projects are going? Because in the next lecture, we'll give you some space to talk about your project, and maybe Sorry, yeah, I didn't take a look at the chat. I noticed that some people didn't have the presentation. But thanks, Dorian, for sharing. And yeah, that's also on the Discord, as well as the previous version or previous lecture slides. All right. So, anybody have any questions about their current project that they're working on? I'll stop recording now.